Given the mean and standard deviation of a normally distributed random variable, we can find the probability the random variable falls into some interval. But what if we knew the probability? For example, suppose we knew the percentiles. We could then recover information about the random variable. For example, find the z-score for which the probability that x is less than or equal to z is 0.8, where we'll assume that x is a normally distributed random variable. So ordinarily we'd use our z-score to find a probability in the body of the table. Since we have the probability, we look for the probability in the body of the table and read off the z-score. Since the table doesn't have infinite accuracy, we'll start by looking for the probabilities closest to 0.8. In our table, we find 0.7995 and 0.8023. Since 0.7995 is closer to 0.8 than the other value, we'll use that. And this is in the 0.8 row, 0.04 column. So the z-score is 0.84. Now, sometimes we might want greater accuracy. So here we want to round our answer to 3 decimal places, which is a problem because the table only gives us 2 decimal places. And on a standardized test, you might not be allowed to use more sophisticated technology. So if we need more accuracy from a table of values, we can use linear interpolation. This works as follows. The 2 closest z-scores were 0.84, which gave us probability 0.7995, and 0.85, which gave us probability 0.8023. So what we want to do is we want to look at the ratio of the change in the z-score to the change in the probability. So our z-score changed by, and the probability changed by. And so this means for a 0.01 increase in the z-score, we obtained a 0.0028 increase in the probability. Now we want our probability to be 0.8. So for 0.7995, we want to increase the probability to 8. So we want to increase our probability by this amount. And so to get from 0.7995, that's this value, 0.84, to our desired probability, 0.8, we only want to increase the probability by 0.0005. So we'll set up a proportionality. The actual change in z to the actual change in probability to the desired change in z to the desired change in probability. Now our actual change was an increase of 0.01 for an increase of 0.0028. The desired change, well, we don't actually know how much that is, but we do know how much we want to increase the probability by. And so we can solve this proportionality to find our change in z. Now remember, this is the change in z, so the actual new value will be our original value, 0.84. Remember, that's where we changed from, plus that small amount. And then we'll round that to 3 decimal places for our answer.